Hi everybody. I thought I'd make a video and talk a little bit about this intermittent fasting, extended fasting study that I wrote about yesterday because I think it's of pretty great interest for those of you who like this sort of thing, the science behind it. Intermittent fasting, as those of you who read my site and my books know, is an anti-aging protocol. By going without food for a certain period of time, it ramps up autophagy, which is the cellular self-cleansing process. Autophagy declines with age. So increasing autophagy is a very good way to clear cellular junk and to get the organism back to its youthful state. When organisms, including humans, are young, they have high levels of autophagy, and it can be promoted rapidly when going without food. But as they get older, that ability declines. And so by going without food longer, you can ramp up this process. So this is a very important process that gets to the heart of aging. Now, intermittent fasting, the definitions are not totally arbitrary, but they're a little bit loose. But so if you go without food for 12 hours, that's not really intermittent fasting, because that's just normal. You shouldn't be eating between dinner and breakfast. You go to sleep, you don't eat for 12 hours or so. That's just normal. But if you extend that to, say, 16 hours, so you have nothing to eat in the morning until, say, noon, then you're getting up towards 16 or more hours, and that's fasting. That's intermittent fasting. So if you extend that even more, some people take intermittent fasting up to 24 hours or so. Myself, I've done it the longest I've ever done it was about 22 hours, I think. When you get up to a certain point, you're no longer really intermittent fasting, but you're doing extended fasting. So extended fasting is something that would last, say, several days. People have done this plenty in the past, especially for weight loss. But certain scientists, like Walter Longo, who we're going to talk about, have used extended fasting on both animals, and they've studied it in humans, to try to slow or reverse the aging process. Now, when animals or humans go without food for several days, a number of things happen. Their blood glucose goes lower, their insulin levels go down, their IGF-1 levels go down. That's important because IGF-1, that's insulin-like growth factor 1, is thought to be strongly implicated in aging and in cancer. So when it goes down, that is at least thought to be a good thing. The evidence is a little bit ambiguous there. Inflammation goes down, C-reactive protein, etc. Lots of interesting and good things, seemingly good things, happen with extended fasting. Longo, the scientist who's done a lot of this, is also he's done extended fasting experiments with animals, with mice and rats, and they have regeneration of stem cells, restored immune function. In one interesting study, the immune cells were just about completely regenerated. What happens is that the body is consuming itself during extended fasting, and then when the fast is over and food is eaten again, the body regenerates these immune cells. So it all looks really good. In his latest study of Walter Longo and his colleagues looked at a group of humans, about 70 of them, I believe, and put them on what he calls a fasting mimicking diet. So the fasting mimicking diet is something that's intended to ease the pains of extended fasting. So going without food for any length of time, a matter of days, is difficult, and plenty of people have done it, but most normal people do not want to do that. And so Longo has developed this fasting mimicking diet. He's actually got a company called Prolon, and I'm sure he's envisioning making some money on this. No problem with that. In any case, what he does is he wants these people to fast for 5 days a month for 3 months in a row. This is the protocol that he's been using, and with this extended fasting, this fasting mimicking diet, these people can eat on these days while the physiological processes are not distinctly different from fasting. So this fasting mimicking diet is a low calorie, low protein, low fat diet that will allow IGF-1, insulin, glucose, etc. to go down while still providing I think it's 1 meal a day is all this is. All they eat it at once. So on the first day it's about 1,000 calories, and then on days 2 through 5 it is about 700 calories. So that's low, and it's low enough to cause some significant weight loss. So in this latest study, this group of people did this fast for 5 days a month for 3 months, and then they measured their biochemical parameters of interest, and they were good. They blood glucose, insulin, etc. dropped. Their blood pressure went down. They lost weight, and so on. So this all looks very good, but I was rather underwhelmed by this experiment. And so why is that? These are seemingly good results. Well, the reason lies in the people that went through this study. These people were pretty much like typical Americans. They were overweight. About 35% of the people in this study were of normal weight. That is, they had a body mass index less than 25. With the caveat that having a BMI of less than 25 does not guarantee that you are physiologically normal, because there's this phenomenon called normal weight obesity. If you have too much body fat, too little muscle, don't exercise enough, you can have a normal BMI but still be metabolically abnormal, morbid, obese. But in any case, 35% of them had a BMI less than 25, but about 35% of them were overweight with a body mass index between 25 and 30. And about 25% of them or so were obese with a body mass index of greater than 30. So the reason that this is important is because anything that gets these people to eat less and to lose weight is going to be healthy for them. Doesn't matter whether it's a fasting mimicking diet, an extended fast, intermittent fasting, more exercise, a calorie restricted diet, a low carb diet, anything that helps these people to lose weight and get back to a normal human physiology is going to be healthy for them. So this study, I'm afraid, didn't really show any distinct anti-aging effect. It just showed that by doing this fasting mimicking diet 5 days a month for 3 months in a row, you get healthier. So that's great, but you have to keep in mind that this does not show that this study slowed aging. Now, this phenomenon is widespread in the world of aging research. Most of studies on aging use animals, of course, rats and mice, and a lot of work has been done in the area of calorie restriction. So when you take a group of rats or mice and you restrict the amount of food that they can eat, cut their calories by anywhere from 10 to 50%, and they live longer. So what is behind this? There's been a huge amount of research going into this, and thousands of papers written on what could be the reason for restricting food leading to longer life. If we could figure this out, we'd have huge clues into what causes aging. And a lot of very plausible ideas, not all of them mutually exclusive, have been generated from this idea of calorie restriction extending life. So far so good. But what is the problem with that? The problem is that these animals, these rats and mice and other animals, are compared to control animals. Control animals that are allowed to eat what they want. They're not restricted in calories. So then you see how long the control animals live, and then you see whether the calorie restricted animals live longer, which they usually do. But the control animals are not normal. Lab rats that are kept in a cage become obese. They are given food basically ad lib 24/7. It's there in their trays inside their cages. They can eat whenever they want, and they are well, I don't know about crowded, but they're in cages, so they don't get normal exercise like an animal in the wild would. And furthermore, their food is not necessarily very good either. It has sugar, cornstarch, vegetable oil, things that I wouldn't recommend any human to be eating, but that's what they're feeding their animals. So would you think that if animals ate less of this junk food, would they live longer? Well, the answer is, of course. If you feed them less junk, they don't live as long. But the question is, do they live longer because this is truly an anti-aging effect, or do they live longer merely because they have not become obese like their fellow control animals that get to eat all they want? These control animals become obese, they become diabetic, and they're in generally pretty bad shape. They get cancer. That's a huge source of deaths in lab mice and rats. So it's hard to determine how many of these calorie restriction experiments have been done using metabolically morbid animals. The same thing happens with other animals, even fruit flies. Fruit flies apparently get adapted to laboratory conditions through natural selection, and they lose stress resistance. So any experiments on fruit flies are using animals that are quite a bit different from what you would find in the wild. Lab rats are not supposed to get obese. When they are in the wild, they're mature at 5 to 6 months, and then they would presumably not gain any weight after that. But lab rats gain weight all the way up until the end of their life. What in effect calorie restriction experiments are doing is comparing these restricted animals to obese animals, and whether the calorie restriction is delivering a true anti-aging effect, or whether it's just preventing them from becoming obese and thus keeping them healthier and living a normal length life. That's the question. So many of these experiments are flawed in this way, and when you read these mainstream stories about these experiments, these great anti-aging effects, you got to take that with a grain of salt. It could be the case that these animals are just being kept healthy, and it's not an anti-aging effect. They've done some calorie restriction experiments on wild mice, and it apparently doesn't work, because the wild mice are living optimally. They get a lot of exercise in their normal habitat, and they don't get overweight. So that's a little piece of evidence right there that something is wrong with many of these calorie restriction experiments. I'll have more to say about that later, and thanks for watching and listening, and talk to you later.